Hello, we will start soon. We had a challenge with our link. So I think most people then would have thought the event is cancelled. It's very unfortunate. Okay, we now have Sebangwayo. I think I saw him on board. Yes, good day. We will start soon. I'm just looking for Sebangwayo. He was on. We had a technical challenge, and I simply have to apologize to you. But I think it's been resolved.
Refrigerator, let's go.
Okay. Sebangwayo, are you on? Even me, I've been kicked out because of the internet. The person who came to check on it also tried. Sebangwayo, can you unmute yourself, please? Sorry, there's something going on, but we had a technical challenge with our link, and now I've been kicked out because it's cloudy and it's almost raining. Sebangwayo, are you on now?
Yes, I'm on. Can you hear me?
Yes, I can hear you. Please, if I'm just checked out, you continue with the session.
Okay.
Let me just see what I can do. Somebody had come to assist, and so we are starting. Pamela, are you on? Pamela.
Recording in progress.
Yes, welcome, ladies and gentlemen, on behalf of the Association of African Universities. My name is Dr. Violet Makuku, Quality Assurance Specialist Workshops Coordinator and Project Manager, HACA Initiative. First of all, allow me to sincerely apologize for the technical challenge that we had. Initially, we had a challenge with our link and then also our network, because there are very heavy clouds outside, and most probably it's going to rain very soon. But we have Sebangwayo with us here. He's going to assist us today with our agriculture engineering under the broad topic of the online teaching of practical oriented disciplines. We want to acknowledge his relentless facilitation of this topic. We are over a month now with him, and I think we have learned a lot ever since we had him on board. For the week of 5 to 8, we were a bit disrupted by the AAU General Conference, but it's now over. And that is something which has been compromising consistency, because here and there we had other events. But I can assure you that from this session going on, we will not have interruptions every Tuesday. We beg you and ask you to ask others who are also in agriculture to come on board and join us for this wonderful session, which comes every Tuesday, 2 p.m. GMT, 3 p.m. Nigeria time, 4 p.m. Egypt time, and Southern African countries time, 5 p.m. East African time. So, ladies and gentlemen, you are welcome. With me also, let me acknowledge the presence of Pamela Boama. She's the one who normally always assists us with the technical support. Sebangwayo, over to you. Thank you. Let me check. Yes, go ahead. You can share. You can start the session. Thank you. Please, ladies and gentlemen, let us call others who had gone out of this session so that they can also join us. Thank you. Because the late opening of the platform compromised our numbers. I thank you. You can go ahead, sir.
Okay, thank you very much for this opportunity. I hope everyone is now seeing my screen. Then unfortunately, my video can't go through because if I open my video, it drags the network. So I hope everything will be okay.
Okay, me too.
All right. Today I will continue. Today I will dwell upon some of the modern irrigation techniques. So for today, I'm planning for the drip irrigation, micro irrigation, surface irrigation, and center pivots. So I hope we will manage to go through. So without wasting time, I'll go into drip irrigation. So drip irrigation is a method that saves water and allows people to use fertilizer through the drip irrigation system. So this fertilizer will be applied through fertigation tanks and will be applied directly to the root or to the station of the plant. So we have the advantages and the disadvantages of drip. So we find that each and every system in life has its own disadvantages and advantages. So advantages of the drip irrigation system, it maximizes water use of the available water that we'll be having, no water being available to it. So we find that in this field that we have in my background, we can say that there's no presence of weed due to no water being available for the weed. So water will be stretched to the plant. And also it maximizes the crop yield, then high efficiency in the use of fertilizers. So as I said, that fertilizers will be supplied directly to the crop. Less with growth or restricts the population of wastes. So we find that if we have less weeds, we also have less pests. So also low labor cost, no soil erosion, and improved infiltration in the soil. Then also other advantages, no runoff of fertilizers, less evapotranspiration losses to the water being supplied. Yes, we can, as compared to soil to surface irrigation, we have that if the water is being supplied or irrigated through flood or surface irrigation, there is more loss through evaporation and also the decreased tillage operation. So we find that in a drip irrigation system, cultivation or tillage activities are directly to the plant, right from the planting stage up to the harvesting stage. Then you have the disadvantages. We have the disadvantages that is sensitive to clogging. So you find that in some other areas where water is affected by the sodic nature of the land, the water will come up with soils, whether the water will be coming from boreholes. So as the water is pumped into the drip lines, the black pipes, it will affect the driplets where the water will be coming out through. So it will encourage clogging of the pipes. And also moisture distribution problem. We find that in some other unpressurized systems, the distribution of water is not even. So in some instances, pressurized drip irrigation is being encouraged, and also some other technical advanced drip lines are being manufactured so that they distribute the moisture evenly. And also the salinity hazards, high cost compared to furrow. We find that the irrigation setup is more costly than compared to the furrow, whereby one is only to construct a canal and extract water through pipes, unlike the drip irrigation, whereby you have to construct a storage tank, the distribution lines, and the drip lines. So we find that high skill is required to design, install, and operation. We find that very few people, or you have to be trained to install such infrastructure, the drip irrigation, the installation, the designing, and operation. So we find that the farmer or the farm operators or the farm workers have to be trained to operate this system. This one is like typically a 1K system that can be used by one, maybe those in the towns. They can install such systems in their backyard, whereby they will be having their drum of water, which they can be filling from the tap or using buckets. And also one can also use a bucket, a 20-liter bucket, maybe will be watering just a 5-meter line of a drip system. So I find that each system, it goes with the area you have. So the area you have also determines the storage tank you must have. So I find this system is a low head drip system due to that stand, which can be a meter high. So that's why it's called a low head drip system. And also next slides will be taking you through some of the components. So this one is affordable, easy to use, field ready. So you find that by someone who can use hands-on, they can install such a system by their own. So this one is the conventional drip irrigation system, whereby this one is for larger irrigation farms, whereby we have that such sand tank which will be trapping the sand. You find that most water is abstracted from boreholes. So in abstracting water from a borehole, it contains some sand, so it has to be trapped in that big blue tank, this one. So by trapping sand, the water will be being pumped into the system without sand. So you find that these ones, as I said, the pump will be there. There are different pumps that can be used. This one is centrifugal, but some can use submersible pumps which are inserted into boreholes. So we have the air valves, which will be removing the air inside the system, and also the bore valves. So we find that in different systems, and the larger the system, mostly air valves and the bore valves will be increasing. So I find the drip system layout, it has the lateral, which is the final line which supplies water to the plant, the distribution line on the sub main line. So there are different terminologies for these pipes. And so also they are also called poly pipes or poly tubes. And also there are other devices that are used, such as maybe end caps, end stoppers, like we used at the end of it. Each lateral, we have the dripper or the emitters. We find that some pipes or laterals come already manufactured to already emit water, but some do have some components or small devices that you have to punch onto the lateral so that it can release water. So there's this one, the flash valve, whereby if you instances in saline, say in clogging instances, you can use these flash valves, or open up these end stoppers to flush the system or the pipeline. So I find that the components of the drip irrigation system involves other components such as the flow back preventer, whereby it prevents the backflow of water, whereby as drip is used in mainly most or any topographical land. So I find that in a system, the water can flow back. So I find that if it flows back, it affects the distribution of moisture. So there's the backflow preventer. There are the valves whereby some are manually or automatically operated. So whereby manually we'll be having a worker who will be opening such valves, and automatically a valve can be opened through technology. So I find that there are filters, which there are different types of filters. There are disc filters, there are sand filters, there are some median filters whereby it's an industrially or manufactured devices which will be installed in the system to prevent dirt or debris to clog the emitters. Then we find the pressure regulators. The pressure regulators, whereby these components will be installed in certain parts of the drip irrigation system, whereby it will be regulating pressure of the water passing through at a certain point. So I find that these regulators will be reducing the pressure of water if it's high, or building up pressure in the system if the pressure is low. Then we have the pipe. These are the poly and the tubing or the rigid PVC. So some we are now adapting to use the HDPE pipe, which is a high density pipe, which these ones that normally come in black. So others are developing other pipes to use. Then we have the microtubing. These are our 1/4 inch of spaghetti. These are much smaller compared to the regular ones that we know, some of which the normal ones comes in 20 millimeters or 16 millimeters. Then you have the emitters. As I said, some emitters come already installed in pipes or already designed to let out water. Some emitters are made to be connected onto the tubing. Then there's two categories of emitters, as I say, the pressure compensating emitters and the non-pressure compensating emitters. Then the pressure compensating emitters, these emitters are designed to discharge water at a very uniform rate under a very wide range of water pressure or other wide ranges of topographical landforms or features that can be in the field. And also true temperature compensating emitters give essentially the same flow at 3 bars, and some are designed to emit water at 1 bar. So you will find that in a system where water will be produced or supplied or pumped into a system, find that some pump water at 7, or depending on the size of the system. So we find that some emitters do have a pressure that they allow water at 2 bars. So these pressure emitters, they will be regulating that pressure, that if the pressure is coming to the final point at 3 bars, it reduces that 3 bars to 2 bars. And if the pressure is very lower in 1 bar, it builds up more water or it stores more water and let out the water at 2 bars. So these pressure compensating emitters are normally useful in areas with the elevation difference, as I was saying, referring to topographical differences. Then there's the non-pressure compensating emitters. These non-compensating emitters output will vary with change in elevation and pressure. So these ones will be heavily influenced by the elevation and pressure. And also these ones do have sort of an advantage compared to the pressure compensating emitters, because if you find that if you have a leakage, the pressure will be building up, rushing to the way there's a leakage, unlike this non-pressure compensating, so that the emitting of water will be generally continuous as compared to the ones with the pressure compensating emitters. So these are the type of emitters whereby each system, or there's the blue, the black, and the red. Some are being, according to one specific supplier, there are color codes that can be meshed with their specific drip lines. So you find that each specific drip line will be having a color code which will be reflecting to each pressure in the system, and also the amount of water being emitted, and also the drip size. So we find that these color codes are not only for decoration, but for color coding for each system, whereby if we are fixing for maybe 30 millimeter drip line, it tends to be operated with a specific emitter. And also we see that these are the online emitters, which I was saying, some of the emitters are designed or are produced or manufactured to be installed on a drip line. Then this one is a drip line. If you can see, there is a hole on this drip line. So this wall is designed to be there. They are not defects, whereby some people will be thinking the wall is a defect, or for some instances, some people even enlarge this wall, saying the water is coming out very slow, yet they are designed to deliver a certain amount of water at a given time. So selection of types and number of emitters. So the selection and type and number of emitters depends on the soil type, the plant to plant distance of the crop or the age of the crop, or even the distance is designed or depends on the specific available drip line on market. We find that in some areas, they are the available ones will be the 300 millimeter, some are the 500 millimeter, some are the 1 meter distance. So in some areas, we find that if there is that specific design spacing, it will affect the arrangement of the field. And also,
Can you, sorry, Sebangwe, there are some who are saying you can increase your volume in terms of voice projection and maybe your volume also. Thank you.
Okay, thank you. We find that the emitter is so selected that the application rate equals the absorption rate of the soil. So I find that in a system or in a field, we don't want our drip irrigation system to over irrigate an area or to under irrigate. So we say there are these emitters are also determined by the soil type. So we find that in a sandy soil, the emitters will be designed to, or the emitter you should install should be slower on emitting water. Or if it's in a clear soil where the water absorption is high, you will have to have a fast an emitter that emits water fast. So in general, generally 30 to 70% of the area is wetted depending upon the plant spacing, the nature and the development of the root soil. And also components of a drip irrigation system. This is a continuation whereby we have a flash cap which is attached at the end of each irrigation line or drip line so that dirt or debris can be flushed out. And also the design parameters, we find that a drip is more suitable maybe from an area as little as 1 meter by 5 meters to a large area of maybe 50 hectares. So I find that the drip irrigation can be designed according to the available space and the type of crops you want to grow. And also the peak water requirements of the crop or plant are also considered when designing such an irrigation system. And also the selection of emitter types, the number of emitter per plant. We find that in some designs whereby maybe you want to irrigate a plantation or a citrus plantation, you find that a specific tree will be having maybe more than 3 emitters to 5 emitters. This will be due to the specific water being required by the plant and the specific season of the crop. So I find the selection of emitter types, the number of emitter per plant, and the amount of water discharged per hour through the emitter will determine how many emitters will be there or available for each specific plant. Then also the water required to be pumped from the well. Find that in some areas, in order to cut off the cost of pumping or the use of energy, water is pumped once into an elevated tank. So we find that when water is pumped into an elevated tank, the water will flow by gravity into the system. And also this depends upon the hydrological conditions in the area and the water requirements of the plant. And also the layout of the soil of the system, considering topography, field shape, location of the water source, calculating sectional flow based on number of emission devices and their discharge against non-pressure. So you find that in instances whereby the water source is lower than the fields to be irrigated, we find that people opt for pressurizing the system rather than erecting some elevated tanks. So also the design of the main and the lateral drip lines, this depends upon the frictional head loss. As I was saying, rather than someone having an elevated tank upwards, they also opt for a pump to pressurize the system, and also selection of filters and other equipment such as the fertigation tanks or chemication tanks, where these tanks are where we apply the fertilizers or chemicals to use for maybe controlling pests and weeds. So we find that this equipment is specifically designed for some systems whereby this is the one fertigation tank you can use for drip cannot be compatible to be used for maybe surface center pivots or the overhead systems. And also the layout of drip system. Water source and the pumping plant location should be located as close to the center of the irrigated area as possible. As I was saying, that some water sources normally can be lower than the irrigation portion. So it depends with what the farmer wants and the type of the level of skilled labor they have. So the main line or the manifold in the drip system preferably should follow the land contours as closely as possible. So I find we still encourage the same system whereby we encourage farmers to plow across the slope. So in drip system also, we encourage the layout of the drip systems to be along the slope. If there is a slope, it should be used for compensating pressure differences due to the change of elevation. And also when water flows down slope, it allows large laterals to give, a given pipe size or smaller size for a given length or of a lateral. And also if a fall of 1 meter in elevation is equivalent to an increase in pressure of 1 bar. So I find in some areas people opt to have maybe a 10 meter elevated tank. So this one will be compensating for the 1 bar. That's 1 bar that they will be having in their system. So I find that some also raise their tanks up to maybe 20 meters, depending on the size of field they are having. And also some fields are characterized by hills nearby. So the water tank will be installed in the near hill available in the area. And also the running laterals uphill should be avoided wherever possible. So by saying this, the lateral shouldn't be running uphill, whereby we have the manifold supplying lateral being at the lower end of the slope, whereby when we are irrigating, the water has to go against the slope. So this one will affect the distribution of water, whereby the water won't reach the upper end of the field. So basically the laterals, or the drip lines should run across the slope. Then to avoid pressure building in supply lines, we do have the application of those pressure regulators or manifolds, or the bore valves, whereby these bore valves will be stopping the flow of water to other lower parts of the supply line. Okay, then I'm not sure if you are seeing the heading. Are you seeing the heading?
Yes, where it says maintenance of a drip system.
Yes.
Yes.
Okay. Maintenance of a drip system is very essential. It's if it heavily influence the successful functioning of each system. So I find that maybe the maintenance depends with the specific components involved in each system. So you have the scent filters. So these scent filters should be backwashed, whereby the scent filter has to be remove the silt and the debris accumulated. The backwash allows the water to come out through the lid instead of the backwash valve. So we find that some other scent filters or other filters do have other outlets to be used to allow water outwards, or some scent filters do have more than one inlet. So we find that these inlets will be used whereby intercontinuous. So you'll be having one inlet being used overall during the operation, and also the other inlet will be used for maintenance purposes, whereby instead of the water using the normal inlet, the inlet that will be normally used during operation will be closed during maintenance, and the other for maintenance inlet will be used for the outflow of water. Then there's the screen filters. I say these are manufactured in the industry. So in a screen filter, it has like the normal filter, but you to be having a screen or some discs. So I find that in a screen, it's like a net whereby it's a hard net where it traps the debris, or some disc which will be pegged in a closed component that will be allowing water to pass through, but the trapping the debris. So you have the chemical treatment whereby the clogging or the plugging of drippers may be due to precipitation and accumulation of certain dissolved salts like carbonates, the magnesium and manganese salts. The clogging is also due to presence of microorganisms and the related ions. So I find that in some industries or some systems, the manufacturers also provide the declogging and maybe solutions. For some instances, people use sodium hydrogen or jig. Some domestic chemicals such as detergents or like jig, they can be used to declog the drip lines. Also, the clogging is usually avoided or cleared by chemical treatment of water, whereby the water is first treated before being allowed into drip lines. Also, this acidic treatment whereby hydrochloric acid will be injected into drip system at a rate suggested. So I find that in some systems, the acidic treatment is preferable till a pH of 4 is observed in the system, and the system is shut down for 24 hours. So I find that some other farms or systems do have monitoring devices to monitor the levels of acidity in the field. So next day, the system is flushed by opening the flush valves or the lateral ends. So I find that there is continuous assessment of their operating efficiency. Then there's the chlorine treatment I was talking about, and fertigation. This is the process of applying fertilizers through irrigation systems. Then the advantages of such mechanisms, it eliminates manual application, whereby if a certain amount of pressure or certain amount of fertilizer is being applied in the field, the manual application can be overcome or to a disadvantage compared to the use of fertigation tanks or the use of chemical tanks. So there's quick and these systems are quick and convenient, uniformity in application, high efficiency and saving of fertilizers to 30 to 40%. So I find that in instances where people are being employed to apply fertilizers, we find that other people end up applying the fertilizers on more than one occasion. When some other instances, some may skip a line unknowingly, maybe not due to that would be due to human error, there's less fertilizer leaching. So I find that in this use of application through fertigation tank, fertilizer leaching is lower, and also the better penetration of P and Q in layer. So I find that the application of the essential nutrients such as phosphorus and potassium is closely managed, and the coordination of nutrition requirements with crop stage or development. So we find that during the initial stage of a crop, the application of fertilizers will be lower compared to the application of fertilizers at the fruit setting stages. So we find that as the crop grows, the supply of nutrients will be increasing, and also possibility of dosage control. So as I say that the monitoring or the application of specific chemicals is monitored at each specific stage. Others like herbicides, pesticide, acid can also be applied. Then disadvantages, we find that due to lack of training, these such components such as the fertigation tanks become toxic to the farm workers, whereby unknowingly people can ignorantly try to clean these equipment, but there should be proper skills or ways to use, and also the availability of protective clothing, whereby people have to wear some gumboots to avoid the acids being spilling on their feet, and also having gloves to protect their hands, and goggles that must to protect their faces. Then there are chances of backflow in a water system for the non-return, but where there's no non-return valve or vacuum valves. So I find that in some systems, where there are non-return valves, once the water it builds up in a system and the fertigation tank is filled by water, there are chances that the water can backflow back into the water source. So this may endanger people, whereby they use that same water source for domestic water use, or maybe for consumption or for other use such as livestock watering. And also there's the corrosive effect of fertilizers. We find that after each application of fertilizers or chemicals, the drip irrigation system should be cleaned. So we find that there are also the lime solutions which help in neutralizing the irrigation systems. And also such tanks, the fertigation tanks, are expensive. Then there's also the clogging. Here, the definition of clogging is whereby the physical causes, which are sand, silt, plastic chips, whereby I find that during the installation exercise, the cutting of the pipes is involved. So in some instances, when the pipes is cut, those chips, plastic chips, are involved, are not removed in the system, so they will find a way to block the emitters. And the chemical causes such as the precipitation of iron or salts, and also the biological causes whereby algae will build up in the system. And that's the first part of my presentation. I don't know if there are any questions.
Thank you very much, Sebangwayo. We can hear from the floor if there are people who have got questions or contributions before we can proceed into the second part. Of your presentation. Anybody can unmute and say something. If none, you can then go ahead with the second part. Hello, Sebangwa.
Okay, I'm sharing.
Okay.
All right. To continue, this is the micro irrigation system, whereby this refers to the low pressure irrigation systems that sprays, mist, sprinkle, or drip. So I find that this one is the micro irrigation. It tries to encompass other systems, whereby this is only not for irrigation, but it's used in many other sectors, such as maybe vegetable markets, whereby the mist or sprays is used to moisturize the vegetables that are being sold. Also, for lawn management, we can use such systems as sprinkler or drip. And also other instances whereby fruits are needed to their fruits that are harvested while left raw. So there are chemicals which are applied for them on them to ripen. So we find that these some systems were adapted from such systems such as the micro irrigation. So the water discharge patterns differ because of emission devices I was highlighting in the first presentation. So I find that there will be some repetition of some other material from the first slide of under the drip irrigation. So the micro irrigation components include the same pipes, tubes, water emitting devices, flow control equipment, installation tools, fittings, and other accessories. The term micro irrigation describes a family of irrigation systems that apply water through small devices. We find that growers, producers, or landscapers, as I was saying, micro irrigation is not only irrigating crops in the field. So I find that growers use this for irrigating, supplying water to their crops, and the producers, some use it to ripen their fruits, and also landscape. Some use it for lawn management and the watering of ornamental flowers or other trees. And also micro irrigation systems are not only in arid areas, and they are in urban settings, because also in some humid and the sub-humid zones where water supplies are limited or water is expensive. In irrigated agriculture, micro irrigation is used extensively for row crops, mulched crops, orchards, gardens, greenhouses, and nurseries. So you find that this micro irrigation system is also used into nurseries, whereby especially the amount of water needed for a nursery will be lower compared to a field. So these micro irrigation systems will be managing the certain water amount being needed for a nursery. So these emission devices, or the actual application of water in the micro irrigation system, is through an emitter. So it's just, as you can see, some of the materials being repeated from the drip irrigation. And also to continue, for emission devices deliver water in 3 different modes, such as drip, whereby it's the normal droplet of water, the bulb, whereby the water will be aerated, so to create a bubble form, like whereby the water will be coming out as a bubble, or a micro sprinkler, whereby the water will be coming out as the normal sprinkler, the large sprinkler, so it will be coming out in a raindrop. mechanism. So in a drip mode, water is applied as droplets. In the bubble mode, water bubbles out from the emitter. In the micro sprinkler mode, which as I say, it sprinkles the water, spray or sprays or produces mist. To find that this there's a we find that for mist to be produced, these micro irrigation systems produce or let out water in the smallest possible amounts, whereby it will be creating mist. So I find that these emitters for each of these modes are available in several discharge. So I find that these emitters are specifically due to the available market. So I find that one manufacturer cannot be having the other emitters due to the market that they are having surrounding them. So I find that in other areas, another emitter of the micro irrigation system will be preferred in that area. So some emitters are adapted to apply water to closely, and other emitters are used to irrigate several plants at once.
We can't hear you, Sebangwe.
All right, so I was closing. It appears like if someone posts a question, it produces a heading that blocks my headings. Sorry. The success of drip, like we are continuing from the last schedule. So I was saying, why is drip irrigation so successful? So it keeps soil aerated, reduces weed growth, cuts down diseases and fungal. So I find that the right amount of water being supplied to a crop or plant will be managed, and this will manage our amount of air in the soil. It reduces the water, the weeds, population of weeds in the field. It cuts down the diseases and fungal occurrence. So I find that fungal, some bacterial diseases are influenced by humid or moisture, by the moisture conditions in the field. And also uniform and efficient water distribution, minimized evaporation and water runoff, enables easy control of water consumption, whereby for a certain amount of water you are feeding into a system, you already know that everything, maybe up to 100%, if there are no leaks, will be going straight into your fields and straight to your plants. So we'll be having an easy management of water consumption. Then the system is more efficient, accurate use of water and nutrients. Then the benefits, this will be the addition from my first slides, whereby it enhances the use of existing resources, finding that in some regions water is a scarce resource, so the water will be having available at you. You'll be assured that you are getting high returns for every drop of water you are using. So it saves labor and also saves the consumption of electricity or energy. It enables multi-seasonal application. So you find that not only drip irrigation, but other irrigation methods are being used to fight against the harsh weather conditions such as frost. So I find that drip is not only for other advantages, but it helps in management of harsh weather conditions and easy operation and maintenance. Find that compared to other systems, drip is easier to maintain, other than maybe pressurized system or sprinklers. whereby we have to monitor the pressure being produced or the water being pumped, and also to monitor the sprinkler heads, which can be reducing the efficiency of the system. And also the components of a micro irrigation system, the water is distributed using an extensive hydraulic pipe network that conveys water from its source to the plant. This one's just a consideration for the drip irrigation. And in general, micro irrigation systems are classified by types of emitters. So I find that this one is not only a drip, but can be also used with a localized irrigation system, whereby, as I was saying, though, there are the emitters which will be at the specific plant. So I find that these emitters will be at a plant, like for instance, as I was saying, a plant can have more than one emitter. So a plant can be having more than one emitter. So we have, for instance, sorry, there's a question popping out, so I have to do this. So you have, see, for instance, for this plant, it will be having two emitters at its disposal. So they will having the one at the other side each. And also, as I was saying, when you are designing for an irrigation system, you can say that here where there are crops is the upper land, it's an upper area compared to this one, here where there are these components. So I was saying that if you are installing such a system, we mustn't install whereby on our right side or the left side will be in higher elevation compared to the other side. So elevation is better managed when the gradient or the elevation is different compared to the when the difference in elevation will be along this sub main line. I hope everyone see my mouse. So the elevation can be going upwards in this way or going upwards in this other way. So pressure will be, or the distribution of water will be managed through these manifolds. I hope everyone seeing these smaller laterals, the sub main line. So by this you'll be having much more management of water, whereby if I close here, the water will be going all through here. And also in other designs, you can also put a bore valve here so that it will be only feeding these four laterals, 1, 2, 1, 2 each side. So you'll be having it easier management of pressure other than having the slope going from the left to right. So the water will only be available at the lower end. Then we also have the main line, whereby depending with your field, the main line will be going to your right. And also, as I was saying, that filters can be installed in many other designs, whereby maybe a filter will be having more than one inlet. So for this system, it has two filters. And also this one can be a valve. So in order to cleanse one filter, for say, I'll say, in order to clean this filter, the one with the mouse and the top one, you have to close there on the outlet. So by closing here, we'll be creating a cycle. So by creating a cycle, in other instances, the water will be allowed to come out through this inlet. And also, if you want to clean the other one, this one, the lower filter, you create another cycle whereby the water will be allowed to come out through this. Or in other filters can be opened at the top, or there are chambers which can be unscrewed. So by unscrewing, you can remove the screens that will be in the filters and also can be cleaned. And you find that some systems do have these chemical tanks which can be detached from a system, whereby you only allow the chemical to be in a tank and to be injected into a system, rather than having this chemical tank be in this position of a filter whereby it has no chances of deattaching the chemical tank. And also we find that some systems are automated, and also this one is a backflow preventer whereby it prevents the systems whereby the water will be not allowed to flow back into the pump. And also by these other advantages of having such a backflow preventer, it prevents chances whereby the chemicals will be flowing back into our water source. And then as I said, these are just a continuation. The line source emitters are suitable for closer spaced row crops in fields and gardens, available in two variations. So they will be the thin wall drip line or the thick wall drip walls. So I find that in different systems or design, some people opt for the drip line, the thin wall, whereby these ones can last maybe for 3 to 5 seasons, and others, such as the thick wall drip walls, they can last up to 10 years. So I find that in someone designing, they will be looking at the durability of such a system or component. And the emitter spacing is selected to closely fit the plant spacing for most row crops. So I find that also these drip lines can be used in, let's say, irrigation, whereby you'll be having your drip line that will be coming from one lateral. So we'll be getting into that person and it circles the person, then goes to another person and circles again. So we find that others are developing more ideas. So we find that they will be creating drip irrigation, whereby the barrier of the drip lines is preferred to avoid the degradation from heat and UV rays, and also the displacement from strong winds. So we'll be having that when installing such a drip system, one can dig a trench of about maybe 10 centimeters into the ground and lay that specific drip line in the soil. So, however, some specialized equipment is being installed or to extract the thin drip line distribution lines is required. So I find that others are now developing equipment being used to install the drip line. So I find that there are others that will be using trailers, or they are like trailers, whereby you'll be having your drip line tubes in a row, so the rolls will be dragged along the field, so will be dragging, so they will be unwinding the tube. So by this it increases the rate at which a drip irrigation installation exercise can be carried out. And also the thick walled drip walls is a robust variation of the thin walled drip line. The internal emitters are molded or glued to. So as I was saying, that there are some already designed or manufactured with emitters already inside the drip line, and also it is more durable because of the considerable thickness. So I find that the thickness of a drip line also is an advantage. The thickness of an emitter of the drip line is an advantage to the system. So I find the diameter of the drip hose is similar to that of the thin walled drip line. So I find that by having a thicker wall line, it's only to increase the durability of the drip hose. Unlike the thin wall drip line, the drip hose emitter spacing is wider and it operates at a higher pressure. So I find that the drip hose is used maybe in those citrus plantations I was talking about, whereby the emitters can be punched into the drip hose. So we find that in a system of a drip hose, these systems will be pressurized, and also these emitters discharge a range of 0.6 to 10 moves per minute. So this one will be given, and some manufacturers give this information on their specific manufactured materials. Then the point source emitters, these are typically installed on the outside of the distribution line. For those that were still online, they have this emitter that was there above a pipe which was blue. So those are the emitters which are point source emitters, which people punch in onto the drip line. So the advantages of micro irrigation saves water, and water supply sources will be limited flow rates, such as small water wells or city rural water can be used. And also this drip irrigation or the micro irrigation, it saves energy. It also reduces the chances of having weed infestations or diseases, and also can be automated, whereby one can control the application of fertilizers and chemicals through their mobile devices or laptops. It improves the production of marginal land. So we find that in areas where they are hilly, the micro irrigation system can be used, and this will be having no chances of runoff and without interference from wind, and also the fields need not to be leveled. So I find that in some areas where they are hilly, the drip irrigation or the micro irrigation system can be used. Then the management is easier compared to other systems, whereby the micro irrigation systems normally have a better management requirements, although this can be said to be easier when the right person is trained to monitor such systems. And also soil particles, algae, and the mineral precipitations can block the emitters. So I found that with the regular maintenance, it becomes easier to manage some systems. And potential damage, you find that comparing the thin wall and the thick wall, the thin wall has a higher potential of being damaged by animals, insects, whereby maybe others will be having maybe their goats or cattle maybe passing through their fields. So in chances it can trip by dragging the drip lines, and also the drip or bubble irrigation systems need additional equipment for frost protection. So I find that in other areas, in order to protect their system, they timely irrigate their crops during those predicted for frost hours, like maybe for instance, you anticipate that frost is likely to happen between the early hours of the morning. So that's when they plan their irrigation program. So instead of the pipe, the drip lines being hit by frost during the early hours, people will be irrigating. So by irrigating, the movement of water will prevent the drip lines being shattered by frost. So the high initial cost, these are the disadvantages. The micro irrigation systems are ideally for high value installations such as orchards, vineyards, greenhouses, and nurseries. So these ones are more for high end value crops. So where will you behave? You can't install such a high costed system for lower fetching crops. Then the potential problems, these include clogging, as I was saying before, whereby the micro irrigation systems require a very good filtration system, whereby we have those screens that are 200 mesh. So we find that the smaller the screen size, the less the cases of clogging. And also moisture distribution. The moisture distribution depends largely on the soil type being irrigated. In some soils, deep sands with very little lateral water movement or low capillary forces can create more problems. So as we know, the sand soils allow water to move. They are going downwards, unlike the clear soils which allow the capillary movement of water. And also the weighted volume, such as shape. Yes, a shape approaching a cylinder rather than a hemisphere, since gravity forces are dominant. Under this condition, it is difficult to weight a significant portion of the root zone. So we find that in other systems whereby you integrate the use of maybe a drop irrigation system and mist irrigation system, we find that in a drop it will allowing for the gravitational movement of water, but the moisture of the mist drip system will be allowing the capillary movement of water. Other problems, the increase in number of emitters per plant, the improve water distribution, and so as a result, coarse sands will require much closer spacing of emitters than finer clay soils. And also most of the plants can perform very well under these conditions, which can be designed for that specific field or specific crop. However, there is a minimum volume of roots which is to be weighted for a reduction in yield while will be observed. And also other problems such as salt buildup, as I was highlighted in the earlier presentation, and also the initial cost, filter, chemical injectors, and possible automation components at the cost of the micro irrigation system. And also adding other problems, they require filtration equipment. It influenced by water quality, where the water doesn't have to be having debris in it. And also in some instances, the water treatment must be first done before being supplied into an irrigation system. And also the level for selection of automation equipment. We find that people do have little knowledge in selection of the automation equipment, whereby one farmer can admire the system being used by the other farmer next to them. So without proper knowledge, they can opt to buy the same system, but there are different capacities. The automation equipment which will be differently or be having a different level of efficiency. And also the insects, the infestation of insects can create additional maintenance problems by chewing the holes in the plastics. And also this is mainly maybe due to the clogging, whereby you find that insects do favor maybe salt or maybe in search of algae. So they will be chewing the emitters in search of food, so they will end up damaging our systems. And also some components of the systems can be easily damaged by people unaware of their locations. So you find that in those sub-irrigation systems, people maybe due to other practices, plant practices, maybe such as cultivation or weed management, people end up damaging our equipment. And also the micro irrigation system does not provide significant frost protection, therefore it is not suitable for that purpose. So I find that this micro irrigation system is less recommended in those areas affected by frost, or some do use it during the other warmer seasons. Then when they approach the frost seasons, they change their equipment or drip lines. So in other systems, the micro irrigation system do has the pumps and the power unit, whereby the type and size of pump selected will depend on the amount of water required, the desired pressure, and the location of the pump relative to the distribution unit. As I was saying, that the pump can be installed at the water source, which can be located downwards of the irrigation system. So it means that there will be a need of bigger pumps compared to a system whereby the irrigation system is at a lower end or on the lower elevation compared to the water source. So the pump system will be smaller. And also the electric pump units or internal combustion engines, such as generators, can be used, solar pumps can be used. It is now being opted for by many people, as they will be relying on the solar energy. And also electric pump units is being preferred, whereby the people use electricity straight. And those are the filters, as I was saying, they are the screen, disk, and send filters. And these are the explanations whereby the screen filters are the most common filters in the most cases, the less expensive. And also these screen filters are excellent for removing hard particles from water, such as sand. Not good at removing organic materials such as algae, molds, and slimes. So I find that these organic materials end up clogging or blocking the pathways of water in these screen filters. And also in other cases, they simply slide through the walls in the screens by temporarily deforming their shape. Also, the outlet is opened and it is hoped that the debris wash out of the flush outlet with the water. So you find that there are different mechanisms manufactured when manufacturing these screen filters. So they will be helping us to manage these filters. And also the media sand filters. These are whereby maybe chambers are created whereby people take the normal sand, but it mustn't be that fine sand, and is put into the chambers, and these chambers are closed and then linked into the irrigation system, whereby the water has to pass through this sand filter. So naturally, the water is maybe in rivers, water is filtered by sand. So that's the same mechanism used through these sand filters. So in most cases, the media materials is of uniform size or maybe crushed sand. So you find that in those areas where there's less sand, people do manufacture their own sand by crushing rocks. And also this sharp-edged say that organic which would otherwise them or slighter their way through the small spaces. So it's fine that the use of the semi-uniform sand size is very important, and also this is why it is important to use sharp media. So you find that by crushing sand, it creates rough edges whereby debris such as maybe algae can be trapped or stick onto the media. And also the media filters are the types of filters most commonly used for high volume cleaning of water from rivers and lakes. So we find that in other municipal services, they are already using these sand filters. So as I was saying, they are used for both large farms and municipal water systems. And also the most often used are the 90 centimeters to 180 centimeters diameter, the rounded tanks. So there are some people who have noticed such tanks may be a size of a drum or a bucket. These are installed near a drip, a borehole system whereby the water is pumped down from the borehole into the sand tank first, whereby to be filtered, then goes into the system. So in some instances, these media filters are cleaned by back flushing, or in some instances to reduce the build-up of bacteria. These sand filters are opened and the sand is allowed to dry. So people will be saying that by drying up of this sand, it will be killing the bacteria. So after the sand is dried off, it's returned back into the sand tank and back into the system. And also the sand will not flush out, and soon the filter will be completely filled with sand, and which will have to be removed by hand. And also media filters must be carefully meshed to the system flow rate for proper operation. So I find that at a certain system flow rate, a certain size of your filter is used or is meshed for that system. So as I was saying,
okay, let's see what we have, but we need to leave time to attend to the question and answer session.
Okay, I was finishing up.
Okay, thank you.
Okay, as I was saying that there are systems whereby you have two filters being installed. So these systems are interchanged whereby there are these valves. So by closing either the valve, the water direction goes to the other side. And also you can see that the direction of flow is changed. And also the purpose of filtration. Then there are the set figure of filters. Then there are the control components. That's all.
Hey, maybe I rushed you too much, but let's.
It's okay.
Sorry, we'll see what we can do. Next week we can start from there. I'm now going to the chat panel. While this time attending to the chat panel, you can scroll. Okay, that's fine. I thought you would scroll gradually the what, but let's look at
Trying to share.
Okay, let me and full screen. Yeah. So what we want to look at are the issues here. Good presentation there. Is there any way of doing things like the setup of the drip practically with students considering the current situation? And then I wanted to respond and I started responding in the chat panel that when the COVID-19 pandemic broke out, we realized the challenges which were on the teaching and learning of practical-oriented disciplines. All the other support workshops which were being done were literally supporting people on theory aspects of disciplines, and even those which are practical oriented, people continue to concentrate on the theory. And so we came up as AAU to say we are going to have these workshops which are entitled the online teaching of practical oriented disciplines. And so what you have asked about, Mr. Chigede, is in the right direction, that these sessions are meant to address challenges of the teaching of practical oriented disciplines. And after this theory session, we look forward to having something here on the Zoom platform, which now you as lecturers or students would also learn maybe how to teach this topic online, even if you don't have your students on the ground. Looking at that further, there was also let me quickly check. It seems there was another question from Ngozi, who was saying, please, what could be the problem on my crop? I used the drip irrigation for Telphyria occidentalis. Oh, she has given us the botanical name. Can you give us the name which is not botanical for everybody else to get it, particularly us who are formulating these workshops but are not really specialists in botany or agriculture? Last dry season, but my crops did not do well and the roots did not form well at all. What else can I do best? Is it carrot? Is it beetroot? Somebody should respond to us. Yes, may you please respond to the that one from Ngozi, say Bangwayo. Because while we are doing these workshops, I know there's the technical side and the skills acquisition side, but we also have knowledge acquisition. We actually deepen our knowledge of some of these topics which we ordinarily normally teach. Thank you very much.
Okay, thank you. I'm trying to look up for the meaning of the terminology used.
No, the person who put it in there should tell us. Ngozi,
Okay.
Ngozi, please tell us, are they carrots? Are they beetroot? What are they whose roots did not develop well?
It's coming up like maybe pumpkins. I'm not sure if it's okay. It's correct. So the issue that mainly becomes a problem with drip irrigation might be the development of roots. So I'm not sure is this drip irrigation that they are using was their first irrigation type they used, or they changed from another irrigation type. I'm not sure if maybe they can respond to that. So there are stages whereby we encourage people maybe to, after maybe transplanting their crops, they mustn't already supply water continuously. So there's a stage where we call starving of the crop. So by the starving of the crop, we'll be reducing the application of water. By reducing the application of water, we are encouraging the crop to develop its own root tip. that will go deep into the soil other than relying on the water that we are supplying. So for instances, on might be farmers who have came across this, when we are having maybe crops in a normal field, which is rain-fed. So if we have chances whereby we plant a crop, there's continuous supply of rainfall. Once the rainfall is gone, we find that the same situation comes back, whereby the roots will be already applying by the readily available moisture in the top water, in the top soil profile. So he's saying that there are stages whereby maybe after transplanting, you make sure that maybe the first 3 irrigation sections or first 2 weeks of irrigation, you'll be applying the specific amount of water needed by the crops. But then for the 3rd week, you starve the crop so that it develops its own root tap that will be going deep into the soil. So it depends with other agronomic practices and the specific type of crop. I'm not sure if their question has been answered.
Yes, I think you have done justice to that, which is very important. So what I would ask is that when our participants leave, we can remain on the platform. So tomorrow it's yet another special day where we are trying to make sure that we continue to support people, support institutions on how to teach and how to make sure they have robust systems which can continue to help you to deliver online. Because right now, the globe, the whole world seems to be going into another serious wave of the COVID-19 pandemic. And with that, it's sad news to all of us, but still we should continue to find means and ways of leveraging on the available resources to make sure that we do not close the doors of the institutions. So this is what we will do. I've put up the link there in the chat panel, and I'm saying, please share with many regarding tomorrow's session, African Higher and Tertiary Education, Quality and Quality Assurance of ICT Infrastructure, Internet Services and Distribution. It will not end here. Definitely, as we discuss such issues, we will also touch on the solutions. What solutions are available for us to make sure that we continue with the teaching and learning? That is very, very important. Please, if I don't have your WhatsApp number, just send me a hello so that you don't miss out on the different opportunities from the AAU. Sometimes we want to send out available jobs elsewhere. Sometimes we want to send out grants applications. Sometimes we want to send out workshops. But if we do not have, if you do not have your contact details, particularly WhatsApp, for me, in AAU, WhatsApp is official communication. And so if I receive things on WhatsApp, I'm most efficient and fastest there. So, yeah, that is it. Ladies and gentlemen, allow me to end this session and make sure that we join tomorrow's session. Can we have our cameras on? We can have our cameras on so that I can take a photo. Once again, while the people are putting on their cameras, I just want to apologize for today. You know, normally we are more than this. We are more than this, but this time we can't be more because of the challenge that we had today. I don't know what happened with our link. And so there was a technical challenge and most people could not join us. But it's my sincere hope that people will apologize. We are apologizing and we hope that you will accept our apology. So that is it. Let me just take a photo of us and then we can call it a day. But thank you so much for coming on board. Right. Just a minute. Okay. Thank you very much. Tomorrow's session, like I said, it's a very important session, which I hope a lot of you are going to invite others to attend, and you are also going to attend. Till we meet again, bye-bye. And thank you. Call upon the others in agriculture to join us. We can't continue to be few because there are many universities with agriculture faculties. Why is it that our number is not increasing if we are inviting fellow colleagues in these faculties? Thank you very much and bye-bye.
Bye. Bye.